Hello everyone. Thank you for joining for the session 4 of the ML paper reading club from GDG Surrey. My name is Darshan and I'm one of the co-organizers at GDG Surrey, and we are a growing community of students, developers, and tech experts, who come together and share their knowledge. And today is similar kind of a session. Uh, I would also like to shout out all the team members that we have. They are a dedicated, team of people who have made all the online as well as physical events possible. And whenever you meet us, you'll find us running around, and managing the event. But yeah, thanks to you for your participation to make all these events successful. And I hope we can make this ML paper reading club successful as well. So yeah. So as I said, for the ML Paper Reading Club, today we have Sergey, who is going to lead this session and take us through the remaining chapters of the current white paper. Before we go through that, I would just like to introduce Sergey. So Sergey, he holds a master's degree in computer science from ONPU. He has over a decade of experience in supply chain industry, and he specializes in automating passenger and freight transportation processes. Currently, Sergey is a CTO at shipnext.com, where he built a skilled team from scratch. He also leads a technical strategies and embrace cutting edge AI technologies, driving innovation every day. So over to you, Sergey.
Thank you, Dasan, for such invitation. Yes, introduction. Let me start from reading this paper. So first of all, I want to say also thank you all that joined this event, and we can start. So try to manage with the share screen because it's a little. As I faced several times with the issues, but I will try. So,
Yeah, I can also share the link in the chat. I think Carlo has a hand up. So Carlo, do you have any question?
yeah, this is
Yeah, I
Can you
don't
see the
think so.
screen?
Yeah. Please go
Okay.
ahead.
Okay. So the seventh chapter is so describing the process of how the SPG works on a programming layer. So it describes the SDK and the rules and how it deals with each other. And we face with the three layers of this programming interface.
Sorry to
And
interrupt you, Sergey.
yeah,
Are you sharing your screen?
yeah, I'm sharing. So okay, grant access to share. Oh, sorry. I cannot do
Ye-
that. Can you share the screen with so we will simultaneously scroll through the document because I have a lack of.
Okay, let's do that.
Sorry about that. I faced several times. I don't know why, but I faced several times with these issues, and I cannot.
Okay, so in that case, let me share my screen. I have actually granted you a moderator access. I'm not sure if you should be able to do it right now, but if not, let me just go ahead and share my screen. You're muted, Sergey.
Okay, we'll try to share again. Yeah, just a second. Can you see the screen?
No. So
No.
yeah, let
Grant
me do
access
one
to.
thing. Yeah,
Yeah.
let me
Okay.
do one
So
thing. I can go ahead and share the screen. Okay. think it should be visible.
Yeah,
Are you
I
guys
can see it.
okay? So let me go back to the chapter
7.
7. Can you help me with the page number?
Page number, yeah, just a second, 73.
Okay.
73. Just scroll down. Yeah, this one. But you got only some annotated version.
Okay, you want me to share the annotated PDF?
Yes, but this link that I gave you, is it? I think it's should be annotated. I can post here. Because I've checked, it should be annotated.
Okay.
Yeah, this one. Mm-hmm.
So this one is okay, or you want me to open the PDF, download the PDF, and then help you
It's
present?
also available to load through the GitHub. I mean, online in the browser. It's also available.
Okay.
Okay,
Okay. I
so
hope you are able to see this. Yeah, please go ahead.
yeah, we can start with this chapter 7 is describing how SPG improves. So it introduces SPG programming layer and explaining how it separates the main model from underlying engine using SDK and operator framework. So it's enabling fast knowledge graph deployment. Also describe about 3 layers. This is business layer, business application, domain knowledge service SDK, and operator. So that's why I've annotated this in SPG semantic programmable architecture. There are like 3 layers that provide users programmable interactive interface to model, to construct and reason for domain knowledge graphs, and that is well supporting the continuous iteration of the domain knowledge graphs. So basically is when your data has been changed, so you can apply the changes to your structured data as well, and through the understanding of these ontologies of this structured data with the help of LLM, then it will be well described in the further pages. So we can scroll just a little down on the next page. And yeah, this is 3 layers of SPG engine that I've mentioned. Yeah, SPG. Yeah, scroll just a little down. And let's talk about the knowledge construction. So knowledge construction framework, the operator framework for building the domain knowledge graphs based on structured and unstructured data or semi-structured data that is written here, with the help of writing the rules. So we can write rules manually. So we can, looks like a code, and it also has interfaces with Python, and so it's very flexible, and you can write your own rules. And these rules also could be written automatically, so it could be processed with the help of LLM. So with then, simplifying this, we can mention that LLM will write rules instead of you, and you can only help it to write it more correct way. The construction and transformation from data to knowledge. So with the help of SPG framework, data could be transformed into knowledge through the programmable operators. So Later will be described that operators, but operators enabled structuring of all unstructured and semi-structured data to obtain knowledge elements. So like subject mounting operators, where operators involve mounting entities, events, and concept types, and a combination of entity and event properties. So summarizing this, we can say that construction and transformation of data into knowledge, categorizing operators for information extraction, entity fusion, and classification. This for purpose, the only one purpose, enhance business application. We can scroll just a little down to the next page, page 75. That page explains how SPG modeling improves data processing by reducing redundancy and maintaining. Sorry, I'm not annotated here, but yeah, so just but I will. I can say verbal. But this page explains how SPG modeling improves data processing and by reducing redundancy, yeah, and maintaining structured relationship demonstrated through pseudocode example. So we can see the pseudocode here that demonstrates how to eliminate redundancy of the data, yeah, we can see the more. Yeah, simply use this bin2 method that provide the relation between entities and group of entities. So simplify this LPG, the comparing LPG SPG modeling. So SPG improves over LPG by reducing raw data preparation. So reducing the cost and enhancing data structuring. So efficiency gains. SPG separates separator framework from implementation and allowing standardizing knowledge construction. So SPG provides us more standard way how to structure your data and how organize the connection between that structures. So as I mentioned before, it's Python-based, has Python-based operators, and then developers can quickly implement operators using Python and bind them to the specific knowledge graphs and graph types. Yeah, we can scroll just a little down to the page 76. Yeah. Page 76 introduce logical rule programming, detailing on built-in predicates. It's logical rule knowledge and reasoning decision rules for automating inference and knowledge graphs. So this scheme shows that there is a relation that organize the data in the and defined logical rule knowledge. And it could be nested and use that knowledge by the well-formed predicates. So later we can also could see the that you can organize the structures and name it, give the name, and then operate only by the name. For example, if you have description of like a programmer who manipulate the data, and we can call it fraudster, yeah, and then we can operate with only this entity like fraudster. So later we can see this example. Yeah, you can scroll just a little down to the next page. Yeah. This is an example that shows us, yeah, about this page. Can you scroll just little down? Yeah, how it works. So this page shows the graph representation and introduces logical rule programming that detailing built-in predicates, logical rule knowledge, and reasoning decision rules for automatic inference in knowledge graphs. So we can form the knowledge graphs with the help of rules, and as I mentioned before, we can use it like as some entity with code entities. Yeah, and this is very helpful in the main specific knowledge graphs for better reasoning and understanding of connection and facts. Yeah, can you click this one, this yellow exclamation balloon? This one. Okay, well, does it work? Okay, we'll scroll just. Okay.
Yeah, it doesn't do anything if I click on it.
Okay. Well,
Is it because I'm not in the PDF? I have to actually download the PDF and then, right?
okay, so
Yeah,
we'll
let's do that.
give you some comments. So SPG enables feature extraction and some graph sampling for knowledge graph learning and integrating with the TensorFlow, PyTorch, and supporting multi-hop sampling. So it's very helpful for structure extraction and future computation. It's very helpful for advanced AI modeling. So we can see that the sampling comparator that help us to build more organized structures, and it's also available with a PyTorch and TensorFlow operator. So next page demonstrated this code written in Python, and it provides like see the code, but the concept of multi-hop subgraph sampling in GCN algorithm, and in some, can you scroll to the next page? You need to load more pages.
Yes, let me just stop and open the PDF so that we can see your comments as well.
Okay.
Yes. Okay, I hope you're able to see the PDF now. Is it blurred? Is it
Yeah,
blurry
just a
right now?
little blurry, yeah. Yeah, but it's in general it's readable.
No, let me try making it a bit better. Is it better now?
Yeah, much better.
Okay. So yeah, you wanted to check out this comment, right?
Yeah, this, but I already read that. I can read again. So yeah, this SPG enables the future extraction of subgraphs, sampling for knowledge graph and learning, integrating with the TensorFlow and PyTorch, and so support multi-hop sampling, structure extraction, and future composition for advanced AI modeling. Yeah, then we can see in the next page, we can see a pseudocode that this following pseudocode representing us the concept of multi-hop subgraph sampling in GCN algorithm. So summarizing that, we can so this is introduction layered abstraction of SDK programmable framework, and it just few lines just to understand that just presentation of that framework, because it's not well described in this paper. They give us few examples and that how to form their rules, and they focus to get a more reliable and full description of the that framework in the next paper. It's also available on the official website. On the they have a documentation of KAG framework and and SPG usage examples. So I think they on the step of forming the new white paper, like white paper 2.0. But SPG employs a sampling operator module to integrate the graph data and machine learning, supporting multi-hop and weighted sampling. So it allows an efficient efficient knowledge representation, and its layered SDK framework ensures the scalability and flexibility. Yeah, that's written there. So we can go further to the next chapter that describe the SPG-LM layer. This is that I mentioned before, but it is like like sugar in that framework that allows us to build that rules with the help of LLMs, and then we can organize the data structures that and linked entities in that structures that will help form the more reasonable answer and reduce a hallucination. Very, it's like repeated action that you can, with the help of LLM, you can form the rules, you can form your data structure, and provide that structure for your LLM to produce more accurate answers to the user's questions. So it's really helpful when you want to get more accurate solution to providing some user for financing or for some science materials. So it gives us very good results. So this is a this is a page, this one, 79. So it introduces SPG LM layer, which integrates LM with SPG for interactive knowledge querying, intent understanding, and reasoning. So they mentioned that it helps us, not us, LLMs, to reason more on the data and understand the the material that represented in the text, and they'll then converted to the structured data. So it's very helpful to build RAG. So they call it CAG, because it's knowledge augmentation generation. It's more specific, more detailed way. We can move further to the page 80. Page 80 explains automated knowledge graph construction using LLMs. So combining schema design, human-written prompts, and automated entity extraction. So as I mentioned, LLM help us to build this entity extraction, and with writing several human-written prompts. So we can form that this like ontologies and the form machine representation of like digital worlds and operate on the effects and entities and properties of these entities. So it's very helpful because it's reduced the amount of data that need to be processed by LLMs, and it reduced the fact of different understanding, based on mixing of text data in that documents. Then we can see the several examples of how LLMs, reasoning mechanism works not well, and how this approach gives LLMs more better accuracy. And yeah, we can move further to the next page. So this scheme describes like scenario and connection, and how this approach is nested one by one. This is a interface of SPG that allows to get a fact. Sorry about that. This original document, so it's written in Chinese. But if you want, you can download this framework, and it's allows to switch to the English language. Yeah, so this LLM extraction and optional manual review. So it's utilizing LLM to construct the knowledge graph with the provision and manual review. So you can with the several prompts, you can form the entities and organize the connection between that entity into the knowledge graph that you able to construct. I mean, they aim to construct. Yeah, and this process describes how to knowledge graph, constructing a knowledge graph. So with the help of usage of LLM, entity extraction, relation extraction, another method to construct the knowledge graphs from a large amount of text. So simplifying this, we can reduce the text data, form it into structured data, and if you not really succeed with that, I mean, not accurate, if LM doesn't help you well, I mean, is not well accurate, so you can change it with writing your own rules and change that structures with the ontologies with the programming interface. So yeah, this is the main idea of this framework. Give us like ability to write your own data structures based on the text that you have, and form well-structured data to manipulate it. I don't know, maybe for form domain-specific structure. Very helpful in supply chain industry, in banking and financing industry. You know, when you need to rely on a lot of facts, and then you need to manipulate that facts to build a more detailed, accurate solution. So it's very helpful. Yeah, I can move further to the next page. Yeah, just a second. Scroll just a little more. Yeah, this is page 81. Yeah, page 81 describes LLM extraction and review processes, showing how manual and automated techniques improve the knowledge graph accuracy. So there is that I mentioned that you can do this process could be automated or semi-automated, like that you need to edit that graphs and give some extra properties and connection between the entities. So as I said before, it's really helpful in domain knowledge, and yeah, LLM help to build this domain knowledge completion, and saving this knowledge graph. So simply you can process a lot of text data and form a short amount of, I mean, only facts that you need, and it will be well detailed and accurate.
Sergey,
also.
sorry to interrupt, but there is a question in the chat. Trish is asking, can you share some examples of
Okay,
uh,
yeah, I
use
can
in
share.
supply chain industry? Yeah.
Yeah, later will be written a very good example that one company, so they providing example of how LLM and understanding that text and I mean the worse understanding and the good understanding with the help of SPG allow us to, so with SPG it allows to eliminate some bad understanding of facts that leads to finance lack of resources and so misunderstanding of facts. So they gave as example like the disaster. I thought it's like a dam breakage, water dam breakage led to the this dam demolition provoked some flooding and it reduces like I don't know, drilling of so there are drilling works like they close the mines or mines and but it has an impact on a on the market. So because this mine was closed, the prices of the ore was grow, grown, and LLM with addition without help of this SPG framework. So it figured out that it has a good impact on the industry. But in text, it was written. But in general, all industry, it has a so worse impact because the all prices breaks down, and in fact, so as a consequences, the profit was fall down, and yeah, with correct entity linkage between each other and we detailed forming of these consequences and described that with in the correct way, we get a solution and that help us make a correct decision that uh, that allows us to reduce that impact of such event, but with not correct understanding, like they could have an understanding that it's very good condition that the dam was broken and you got like the price in general market was the grow, but it's not true. So it later it will be well described there about the example about dam and event that not really not correct understood by the LLM and decision making software. I think the next chapter will be well described. That this is a schema how it works. Like we can make it just little. Can you zoom it in? Yeah. Yeah, this is the schema described that user input can be processed through the LLM, and with connection of vector search, this could be vector search, vector database that hold the relation between entities and properties. Yeah, it has a property pattern that allows us to build several subprompts with the question answering prompts. So LLM help us build several prompts that can figure out entity from different perspective and preserving general meaning. So so it produced several prompts, and with answering this prompt, the system built better ontologies but without extra redundancy. So it has like this entities is linked, and if it several times described in this different manner and the different part of text, it remains in the same ontologies and the same data structure. So it's very helpful to not multiply that entities, if entity is described in some other way. So then it's later after that it processed with LLMs, and it produce natural language answers, and this it's repeating actions, like it could be processed several times until ontology wouldn't form it well. So the main idea is to produce knowledge graph pattern, and producing several query samples that also could lead to generating prompts. And with the help of LLMs, they producing query statement that will be well described with this code, and will be stored in a graph DB. So this is like repeated action that LLM based query statement. So it could correct that description that you have in the text, because some facts could be described in two different or three different different ways. But it looks like LLM will ask themselves the text themselves and store the facts in a correct way, with asking these constructions in different way. So it just producing the prompts that more describe that entities and connection that entities is more accurately. So, and then you can ask the LLM of processed structured data, and it will give you more accurate answers. So yeah, we can move further. Yeah, this they mentioned about NL to GKL and GDSL. It is utilities that work in that schema, and yeah, it produced more detailed data sets that we can rely on. Yeah, let's. Can you click on the summary, because it's like end of this. Yeah, SPG, the SPG role in AI-driven decision making. So it's real-world event modeling and yeah, improving LM reliability for enterprise applications. So it's very important to have data that you can rely on, and SPG allows you to build that data in a correct way. If it not really, I mean, not accurate, you can edit that data, but the main idea to build that data structure. So then fact and events and other entities connect with each other, and it forms a well-structured and accurate data structures. Yeah, we can move further. Yeah, this is chapter 9 that describes about. So I need to, chapter 9. Yeah, So it introduces the LLM-driven controlled query answering. So it's tackling the hallucination problem and enhancing reliability in industrial application. This industrial application, this part of supply chain application that I mentioned before. So this is example that I mentioned. It's a dam example of 2019 dam collapse incident in the whale of Brazil. So they mentioned about increase the price of iron ore, resulting in a rise in steel production cost for downstream companies. Yeah. So company known as whale. So increase in profits, but however, this had a negative impact, yeah, downstream of industry, and rising cost of raw materials lead to decrease in profits. So we can understand that if the LLM without SPG doesn't realize that, you know, it leads to the bad conditions, and just realize that it's increased profits, and if it increased profits, so that means that like you aimed to the goal, and yeah, it's like a good condition for you. But in general, if, for reasonable model, some reasonable model, like with the reasoning with help of SPG, it could understand that it's not really well, and so with better understanding of facts and connection with that facts, so this LLM systems and data systems, other data knowledge system could understand that material well, and produce more accurate decisions, like investing in some sphere or not to invest that money, because it could lead to potential, you know, money leakage, and yeah, you know, losing the money. So this like very you know, this example describe us how we need to rely on the, you know, on the data, and to lose that to not lose money, you know, when you rely on the data. Yeah, we can scroll a little further. Yeah, this yeah, this is describe the schema how normal LLM understand the facts, and how the casual reasoning, you know, understand this case. So this chapter describe the how knowledge system, in a knowledge-based system, understand the fact that how SPG has an impact, good impact on how the casual reasoning provide better results. So I don't want to, you know, to pay a lot of attention on that, but in general, it has a lot of connection between the facts in the chain of, like a chain of thoughts, but it's represented inside the knowledge without, you know, building attention chain inside the mechanism. So it's like it's already written connection before LLM could realize it. So it helps to build that connection with small prompts and answers, and then to build that connection that, as I mentioned, it is like ontologies. Yeah, has an entity that you know, a lot of entities that connected with each other, and like and we can see that like iron industry, you know, in general could lead to the losing the fonts, and yeah, this helps to build the more predicate, so more accurate data structures. So yeah, give me the second. I will scroll just a little down. Yeah, SPG enables casual knowledge graph modeling for event-driven insights and dynamically classifying new events through derivable concepts, as demonstrated with this whale 2019 iron ore incident. So yeah. In next page, we can move further to the page number 86, and it's important. It explains logical constraints and reasoning logic. So it's showing how SPG structures causal relations between abstract concepts and real-world business events. So we can see the example of this rule, like nesting of the rule, yeah, one by one, when that describe this situation. So like rule one is like major production accident lead to industry chain event, yeah, and second rule is like industry chain event belong to increase of in iron ore prices, but rule three industry chain event belongs to decrease in steel net profit. So without this understanding, so the LLM could lead only understand that it increase in iron ore prices, and it's like you gain more profit, and but in general it's not true. So as a consequences, we can see that Brazilian dam collapse incident leads to a decrease in profits for several steel companies. It's very important that you can correctly manipulate the facts and constraints. So SPG allows SPG allows express the conceptual classification logic uses the logical constraints. Yeah, and we can form the correct answers with this information gaining information answering and knowledge-based solutions. So yeah, we'll describe it later. Like a summary, like SPG uses logical constraints to classify unconstrained data. So ensuring accurate categorization of financial and industrial events through structured and reasoning rules. This, yeah, we can move further to the next page. This page just give a logical representation of logical properties and external data dependencies. So sorry, 87. Yeah. So it introduces auxiliary data dependencies, showing how SPG retrieve and iterates external data sources, so for better decision making. Simplifying that, we can connect external data as a graph data sources, and or create the data node automatically. So SPG allows us to build hierarchy organized structures and connect external data sources to build more reliable structures and provide more accurate answers. So yeah, after new event instance is generated through event propagation, the new event instance can trigger the classification of the event again. So this is the approach that was shown on the schema, that we can reclassify and remeasure the weights of the entities, I mean of concepts, that has an impact on general data structure, and this event can be done by using combination of concepts. It's also described the logical rules can be used to define the source of the data. So simplifying that, you can connect the source and organize previously build structures or semi-structured data that will process with the help of this framework that will build structured data as a result, and to build more organized data structure. So SPG enables dynamic event classification using conceptual event indicators and retrieves external data without storing redundant auxiliary information, ensuring logical consistency. So it's very important that I mentioned before that some LLMs could represent same fact or same entity in two vector stores, like two different entities, and it's important to join that entities in the because it's the same entity and it should be classified like same event or same entity to reduce redundancy. So yeah, because it's very important for logical consistency. Okay, we can move further. In page 88, it details how SPG ensures interpretability in causal reasoning, bridging generalized and event-specific logic for risk assessment. So we can qualify the data important, so we can measure that importance of the data. So there are specific operators that can set the data is very important. So simplifying that, it gives extra weight to that facts, and with this redundant mechanism that ask like text with different approaches, different prompts, this entity and events wouldn't be like overwritten or downweighted. So they mentioned about this operator, and we can see by the define the rule pattern, the logical relation of causality, succession, and spatial temporal relation between conceptual events are defined. So they also mentioned about this issue with the DAM, that increase in product price does not necessarily lead to a decrease in product profit. So it's like misunderstanding of different concepts and different facts, so could lead to bad decisions. Yeah, could have a bad impact on your business. We can scroll just a little further. So about the event subject occurrence time, location of each sub-event, composing the factual chain as well as the factual association, semantic association, spatial temporal co-occurrence, or succession relation between these elements. So it provides the basis for establishment and attribution traceability of the relation. So simplifying this, SPG enhances interpretability in causal knowledge, reasoning by structured event ontologies hierarchically, and defining logical causal relationship and ensuring stability in event classification. So it classify the events and sub-events. So composing that factual chain and organize this in hierarchical way. Describe the association, semantic association, and organize co-occurrence, and well-formed relation between these events and entities. Yeah, we can go further. Like SPG is the main like concept. Like SPG enables an interpretation of causal knowledge through factual relations. So it's try to describe in a different way that trying to find the new facts and decouples the factual relation from causal logic and ensuring accuracy and reasoning. So simplifying that, it asks several times about the same fact and the same entity in different ways, and ensure that if new connection between entities or new property will appear, so it give that set the property or the organize that relation between the entities with like with less weight that it's organized. I mean, before when it was structured the data before, and then if it the new occurrence of that fact will, I mean, face again, it will get extra weight and put that into ontology in a hierarchical way. So simplifying that, it operates like this is this entity belongs to, or is like this entity is a other entity, like other naming and or instance of something. Yeah, and in this way it's trying to decouple this entity with the standard predicate. So we can form a conceptual events and specific fact and factual relation to causal logic. So yeah, it helps us organize the data structures with text that was described that facts in more accurate way. Yeah, we can scroll just a little down about comparison. So this comparison about SPG framework and LPG is like a common way that LPG is based for. So give us sorry. So I didn't write okay, just little second. Should be extra information here. Okay, so this comparison of SPG, LPG enterprise causal knowledge graph, so it improves that causal reasoning by decoupling factual relationship and with gaining that fact that they gain from the causal logic. So it validates the like real world event and its dependencies, and yeah, it gives us interpretability more more interpretable than LPG, and with the we have like several in this table. We can see the several issues like that could be related to like entity graph and event classification, so event propagation. So it organizes SPG provides us like more better definitions and describe more describe in better way. Yeah, like these causal definitions describe well, and it's more important that give us native event type definition, so that allows to simplify data modeling and data propagation. So it also supports dynamic classification of events and concepts, and also derives the new concepts from abstract events, and with combination of several conceptual facts found in its text or ontologies. So yeah, gives LLMs, or the mechanisms that rely on the data structures, better understanding of facts, events, and organizing the new structures. So several structures could be not really written in a text, but it can assume that facts have relation of connection. It's also will be written later that some facts not well described in the text, but by reasoning, this framework could form the new facts, entities, and relation between them. Yeah, we can move further. Yeah, okay, it's shown in the table. Yeah, this is the information there. So SPG provides a framework for casual expression in comparison with LPG sufficiently and represent the propagation chain of the events, provide a new practical approach for the rapid analysis and response to the impact of financial events. So this is what I mentioned before. So it's well focused on the financial data, like to not to lose money in case of bad reasoning or bad understanding, worse understanding of facts. So it could lead to huge, losing of the money. So this is this page 89. Yeah, it describes yeah, it compares also this we have seen the comparison. Yeah, this page 19 address the data inflation issues, showing this PG simplifies the risk analysis through standardized property modeling. So we can say that we have tools like allows, standard tools and like regex and some data structures that allows to organize the data with more like detailed way, but it's common feature that we can use in our programming interface. And can you scroll just a little down? Yeah, this is types of data that's very common for programmers. Yeah, like data structures and data types that like strings and that could be nested with the like well-formed entities. For example, you can organize data structures name, like type or ID, and it could be nested with a in a name it type, like font, standard font, or standard certificate, or like standard device, because it's this ontologies already standardized in LPG and as well as in SPG. So, but you can also nest it, transform it, and use it in your own way. Yeah, you can move further.
Yeah, I just wanted to remind everyone. So, yeah, I know that we are a bit over time, but since we started a bit late, we might, take it for a few more minutes. So, yeah, but yeah, this session is already recording. So, we will post
Okay.
the recording of this session, later on as well. Sorry, yeah, please go ahead, sir.
Yeah, the next page. So the page 91. So introduce the cross graph fusion. This cross graph fusion techniques. So demonstrating how SPG integrates data across multiple knowledge graphs for better decision making. So simplifying that, we can nest several graphs that we built before. So because it's well structured and it's like you can use it as a data source, and you can organize it in your like most convenient way, and nest it in your two different projects, and rely on the data. So the data is like movable and reusable, so you can use it as a copy. So for my understanding, it's like also like a classes that you can extend or modify. When you mentioning like OOP, but with additional of extra values that you can inherit from the standard structures. Yeah, you can move further. Yeah, the entity linking. So this page shows that the stage primarily defines how the instances, like user account and person, are corresponded using the entity linking operator. So you can link two entities that I've mentioned several times during this reading. So with one-to-one or many-to-one, correspondence. So you can link that entities with the command, with the syntax. Yeah, we can move further to the page 92. It also explains linking resolution and consistency. It's very important because two different properties could be linked, and you need to set like some constraints and to preserve consistency. So there is consistency management that ensures that data integrity, and reducing this data integrity is with reduced redundancy. So it's important to not have the same like description of the same entity, and this framework is aimed to reduce this the same description of the same entity. It's very important because like it's reduce accuracy of the knowledge base. So it's very important to preserve to lower to eliminate such redundancy, and this approach it's described how to use that technique. And the framework, no, sub framework is like tool KGDSL allows to do that. Yeah, we can scroll. Yeah, yeah, just yeah, this is ontologies that show us how SPG resolve data inconsistencies by enabling logical dependencies. So rule-based entity resolution and transitive relations for advanced corporate data modeling. So we can set it. I just figured that this is pseudocode, but the approach is the same. So we can define some company or entity that is transitive, and then we can organize the old relation, and this relation could be completed based on expert rules. So we can you can form this relation with specific rules that you want to set. So And they describe just a little further. They describe the extension. Yeah, this extension allows to. So they mentioned that in traditional PG models, the data schema are tightly coupled. So uh, if if there some will be some changes in your data structure, you need to organize these changes and to propagate these changes to the whole structures that rely on the data and that have the same structure. But SPG, instead of this, SPG provides the dynamic classification of capabilities based on the concepts. So it allows us to uh, business extension at the conceptual level. So basically, it organizes all the changes. So if you change some property or some relation, it propagate that changes for the whole structure that they rely on, and your data will preserve consistency. So it's very important because this in other framework it could lead to misunderstanding or of some facts and yeah, have a good bad impact on your business. So can you move further? Yeah, this time I'm talking about the SPG enables flexible schema evolution through the conceptual extension. So it provides several extensions that organize the models and the model ownership through transitive relations and enable flexible schema evolution and support dynamic classification for evolving business structures. Yeah. Yeah, this focus, the next page focus on the concept-based and dynamic entity classification in risk mining. So in simple, like classify it as a gambling application and find the difference between gambling and fraudster operator. So depends on the some facts that it could find into ontologies or in the rules or in the taxonomy or in the text. So they introduced like new reasoning predicate code belong to. So it's very important. It's very common in that SPG frame. They use that operator belong to, which links the entities and concept that meet the rule requirements. So it's you can organize the entities with this belong to structure and organize your rules and entities with this operator. Yeah, you can scroll just a little further. Describes that this approach avoids the need to modify underlying data. That's what I mentioned before. Like you don't need to modify the data if you set organize the data with belongs to. So all the data that have such connection will be when there are changes in the business requirements occurs. So it changed all underlying data in business application layer. So building concepts with business concept can be used as types for business users. So simplifying that, it reduces the amount of work that you need to do when your data structure has been changed. Okay, we can move further. Yeah, it gives us this fusion learning of neural symbols and graph-based reasoning. So basically, it's like a combination of RAG that you can organize several understanding of text ontologies that structure data, and you can also provide graphical data like pictures, and it will be well transformed into the data structure in hierarchical way, and then with the help of LLM, it could organize the connection and transform this connection with serial method and rules. That's very some of them common in normal neural networks. It's well described as two categories. Like first, two categories that that it manipulates. So it's objective with rules, and the rules are treated as a prior knowledge and compared into the objective fusion as a penalty term. So with very helpful with the reasoning. So when you get gain like extra points and penalty with understanding some facts. So you get produce probabilities, and if this fact could be destroyed by the other facts, so that get extra weight. So the typical method like semantic loss and other methods. So I wouldn't take your time, just to get deeper in this approach. Yeah, we can move further to the comparison of this. It shows how to convert one predicate to the symbol graph, and how to use it with you. So with generalized and convolution operations, and learning and representation, learning from graph-based data. So you can they aim to connect different data sources, as I mentioned before. It's like structured data and textual data and text data, and it could be also fused by changing of the data, so can better organize the connection between that structured data. So we can move further. Yeah, this one. Just to tell up. Yeah, this one. So this combined SPG with GCN algorithm. So that I meant before, that so you can organize your data and with graph convolution. So you can have like reduce the risk mining and produce, as I said before, produce more accurate way. And this table shows the comparison between SPG and LPG in the risk mining knowledge graph. So yeah. So SPG automates the knowledge graph integration, and it enforces logical consistency and reduces manual schema maintenance overhead. So simplifying that, so it reduced amount of work that we need to, the time that we need to spend on that consistency to import the data structures and organize the data structures in the graph structures. So knowledge application, it's also have some better results, like in so because SPG simplifies query complexity by using logical properties instead of requiring manual deep knowledge of the data structure. So simplifying that, it organized that queries and divides some you know unstructured queries to more simple structured queries and nested queries. So you can organize the data and the queries with the help of SPG in a more detailed and accurate way. And the last one is knowledge evolution. So SPG significantly reduced the cost of complexity of modifying classification structure and in evolving business and environments. So as I mentioned before, so it's like when your data has been changed, SPG allows to organize that connection that we have seen that belong to construction. So it will be also changed when your data will be evolved with the evolution of your data. So in resume, we can summarizing that, we SPG focus on addressing the cost issue for users of the knowledge graph in the field of risk control and efficiently improve user efficiency and reduce usage cost in all stages on knowledge construction and knowledge application and knowledge evolution. So yeah, this is a summary of the whole usage of the document. So the chapter shows describes that SPG enterprise schedule knowledge graph and the risk mining knowledge graph. In the enterprise schedule knowledge graph, SPG provides an event expression framework that efficiently describes the impact propagation relations of events. So this is spin around that fact that this operator belongs to is very common and effective. So it allows to reduce the time we need to spend of mining some data, yeah, and then and as as a result, as a risk mining operations also. Yeah, that's all. It's just the few words like SPG strengths and combining symbolic and neural reasoning for scalable AI models and its advantage over LPG in cost-effective risk analysis. So, summarizing that, we can spend less time to achieve better results, and also most important, accurate results. Providing some extra rules or organize that rules with several extra prompts. So this framework allows us to do that and with spending less time. That's all. That's all for today.
Okay, thank you so much, Sergey. I'll stop sharing. And yeah, thanks a lot for sharing this. And yeah, thanks a lot, Carlo, Jane, and Yashpal for staying on this call. And yeah, thank you, Sergey, for detailed insights and detailed explanation. It was pretty helpful, and I would encourage everyone to stay connected to our GitHub as well as Discord channels. We will keep posting more details about this, and we will also have a recording posted on our GDG
Okay.
Sari main page. So yeah, thank you so much. Any
Yeah,
questions? Any last questions or anything? No? Okay. Thanks a lot, everyone. Have a good day.
thank you.
Bye.
Have a good day. Bye. Thank you, guys.